Key concepts explained simply. RAOs. RAOs help us predict how much a jacket will move in response to waves. Suppose your wave comes and hits the birds and how much a jacket will move. That can be predicted by RAOs. They show how the jacket will tilt, sway or shift depending on the size and direction of the waves. Depending on the size, how big is the wave size and direction, which direction it's coming, based on that jacket will move, right? The jacket, how it will tilt, sway, all these things is given by RAOs. Then C scatter data. C scatter shows how the different types of waves we might encounter. What kind of waves we might encounter, how much big the wave height, how often they happen, from which direction they come. All these things we can take it from the sea scatter data. It helps us understand the range of sea conditions we could face during the during the transport. During the transport, what kind of sea we are going to, what range of sea we are going to face, that we can understand from this is scatter data. Transportation fatigue, that refers to the wear and tear of the jacket that will experience from the movement of the caused by the waves. The more jacket moves, especially the strong or frequent waves, if it is a wave is very strong and very frequently it's coming, it will have a lot of movement. That's because of that it will have face a lot of stress, and that's going to weaken the structure over time. So that's what we call as fatigue. And how they all work together. RU tells us how much the jacket will move with the different wave conditions. With the different wave conditions in jacket, how they are going to move. And CSAT data will tell us what type of waves we will be likely facing it, and how often they will happen. What kind of waves we will likely face, and how often they will face. What kind of wave, like the 2 meter wave height, 3 meter wave height, like that, different wave heights and wave periods, and how often, like very frequently, like very quickly, or we're not very frequently, like that we can come to know from scatter data. By combining these RUs and scatter data, we can predict how much it moves, the total amount of movement, and the stress the jacket might experience. This prediction helps us how much fatigue the jacket will face, so we can adjust the transportation plan, or plan to reduce the risk or keep the jacket safe. So we will have one discussion with Jordan. Alex, I keep hearing about the RAOs and she said scatter data. How do these things help us? How do these things help us with the jacket transportation? Good question. Let's start with RAOs. RAOs stands for Response Ability Operators. It's a way of figuring out how much jacket will move when it can counter space. It's like we are trying to figure out how much jacket will move when it encounters waves. Basically, ROS tells us how the jacket will tilt, sway, or shift in response to waves of different size and directions. It comes from different directions of different sizes. Some waves are coming big in size, some are coming in small in size. So in response to these waves, how the jacket is going to tilt, sway, these things will be these are the things RAO will tell us. If we know how the jacket moves in response to the waves, different waves, we can better prepare its for its movement during the transport, right? For example, if the waves are small, the jacket might move just a bit, just a little bit. If the waves are small, the jacket might move just a little bit. But if the waves are big, it could move a lot. If the waves are big, it's obviously if the waves are big, it could move a lot. That RAOs help us to calculate that. Got it. So how does the C-state scatter data fit with the RAOs? How does the C-state scatter data fit in with the RAOs? This C-state scatter data shows us all the possible wave conditions. So from the C-state scatter data, we will come to know what are all the possible wave conditions, like wave height and how often they happen. You will come to know how often they happen also, and how the conditions also, like wave height, wave period, and how often they happen. It's kind of like a chart that shows us different wave sizes that might encounter, how likely we are to face the each one during the transport. So the scatter data helps us understand the sea, what the sea will be like. We will come to know what the sea will be like. It's a very big sea or small sea, like a very big wave height, and how frequent it's going to come. All these is how big the waves and how often they will happen. How big the waves will be, and how often they happen. Exactly, it helps us predict the range of wave size we are likely to encounter. So we will come to know the range of waves that we are likely to encounter. We can use the data to figure out how often the jacket will experience waves of certain heights. So we can come to know the jacket will face certain wave heights, how often they are going to face. That kind of things we can figure it out. Okay, so we have the RAOs to see the jacket. RAOs are used to see how the jacket will move when it meets different waves. When it meets different waves, how the jacket is going to move, that can be taken from the RAOs. And the scatter data source, understand what kind of wave we will face during the trip, and how do these things help with transportation fatigue. Transportation fatigue happens when the jacket faces a repeated stress from the waves during the transport. Each time the jacket moves in response to the waves, it will experience some stress, and over the time this stress adds up. And can weaken the material, can weaken the jacket structure. That's what we call fatigue. So if the jacket is moving a lot because of the big waves, that cause more stress and fatigue, right? If it moves a lot, it causes more stress, and so fatigue also, more fatigue it can happen. Exactly, the more the jacket moves, more the stress it faces. If it moves more stress it faces. If it faces that kind of movement constantly over time, it could weaken the material, and that could lead to failure. That's where RAOs and scatter come in, right? Yes, exactly. With RAOs, we know how much the jacket will move when it faces certain wave size, and scatter data source, we know how likely those waves are to happen. If it happens with this wave, how much it moves, and how likely that wave is going to happen. So by combining these two, we can predict how much movement and the stress the jacket will experience during the trip. So the if we know the waves will cause a lot of movement, we can figure out how much fatigue the jacket will experience and take steps to protect it. For example, if the waves are going to be big and frequent, the jacket might experience a lot of movement, which will lead to more fatigue. In that case, we might reinforce certain parts of the jacket, or adjust the transportation plan to reduce the risk of damage. So by using RAOs and scatter data and understanding fatigue, we can make sure the jacket stays safe and does not get damaged during the long trip. It does not get damaged. Yes, that's right. By building how the jacket will respond to the waves and how often those will happen and how much stress the jacket will experience, we can make sure it survives the transportation without too much fatigue or damage. This is all about making sure the jacket is ready for the sea conditions that does not get weakened by the journey. Exactly. It's all about planning ahead and using the right data to keep everything safe.